Are you ready for some science?
Yes.
Okay, good. I like your enthusiasm, that's good. We're gonna talk a little bit about displacement. Who's the famous Greek scientist we talked about, who told us all about displacement?
Archimedes.
Very good. Archimedes lived in Greece a long time ago, taught us all about displacement. And displacement at its most fundamental simply tells us that when you put an object into a fluid, it moves some of that fluid out of the way, right? If I take this hammer and just put the hammer handle into the water, what's gonna happen?
Overflow.
Water level is going to rise.
Okay, put that in there. And because there's the volume of the handle replaces the volume of the water has to go somewhere, it gets pushed out of the way, overflows, right? We're gonna kick it up a notch, okay? Are you ready for the intensity?
Should I buckle my seatbelt now or later?
Yeah, I like that. Buckle in, everybody. How many of those pins do you think we could put in that glass before it goes over the edge? How many pins do you think we could put into that?
I don't know, 50, 60.
You don't think it will?
I think it needs more.
We'll try one. Okay, is it overflowing?
Nope.
No. Okay, well, why don't you start taking some pins and just, let's see how many we can get in there. What are you seeing, Alicia?
I'm expecting to see the water come up.
Is it coming up?
Not
But
really.
no.
It's going up a little bit, but like not nearly enough.
Is the water level coming up at all?
Yep, just a little.
Tiny bit.
More pins, more pins. Let's go. Are you surprised?
Yes, because these should dip this.
Keep going, keep going. We haven't spilled a drop yet. Why is this happening? Why can we get that many pins in there?
Because the pins stack on top of each other and there's little cracks and spaces in between each of the pins. Like the water can slide between the pins and stuff, like in the gap.
What does that tell you about the total volume of the pins?
That it's less volume than the handle of the hammer?
Well, yeah, we're definitely displacing water, right? We don't have any choice. The water has to move out of the way of the individual pins. The total solid volume of the pins is actually surprisingly small. Most of what you see there is space that can be occupied by the water. But you know that, I mean, whatever the volume is whatever the volume is. And we were able to get that many pins in there, and even that just raised the level of the water maybe a couple of millimeters. Let's try one more test here, okay? What do we have here?
Cotton balls.
Cotton balls. Are these bigger than pins?
Yep.
Let's see how much water is displaced by a cotton ball. So, I have another glass. Into this glass, I will introduce some crystal clear, pure water. All I want to know is how many cotton balls are going to go into that cup.
I think that all of them are going to go in.
You think all of those cotton balls are going to go into that glass that is already almost completely full of water?
Yes.
Which means, okay, understand what this means. It means if we can get all those cotton balls in there, the total volume of the cotton balls is less than the available dry volume there.
I bet it's either gonna be all of them or like one.
Okay, here, well, try one. Well, it's not one. Let's bring some cotton balls in. Let's go crazy. That'll help you stuff them in.
Looks like tapioca.
Mmm, tapioca. Okay, lots of cotton balls, folks. Let's just get right in there. Does the water level look like it's coming up?
Nope.
No. Keep them coming. That's a lot of cotton.
Water, cotton.
Well, but the water's still in there, right? There you go. But did you think you were going to be able to get all those cotton balls into that full glass of water?
Nope.
That's right. That's
Way
more
more
than
than
57. It's probably close to about 200. Yeah. And again, all the water that we had in there is still in there. Which, what does that tell you about the total volume of a cotton ball? The total solid volume.
Go ahead, Laura.
It's pretty low.
It's pretty low. It's all there. Right? There's not an awful lot there in terms of the solid stuff. So at the end of the day, Archimedes told us that when you submerge an object, it displaces a volume of water equivalent to the volume of that object. But these couple of experiments, they show us
That if something is very small in size, it can go in a lot of water and it won't displace that much.
that's right. I mean, when you take all those All those pins are all that cotton. It's almost all air. And so we have very little displacement of water.